All right, so we've spent some time graphing equations in slope-intercept form, but we're also going to be able to work backwards and write equations in slope-intercept form when we're given graphs, tables, and verbal descriptions. So the steps to write an equation in slope-intercept form is to find the slope. Obviously, if we're doing slope-intercept form, we need the slope. Remember that to find the slope, the letter m, we either need to count the rise and the run, or we utilize the slope of a line equation, y2 minus y1 over x2 minus x1 that we learned about on slope day. This equation is on your formula chart that you were given during tests, so you don't have to memorize it, but I recommend memorizing it. The next step is to identify the y-intercept. When we have a graph, that's going to be really easy because it's a location on a graph. That location is 0, b, and we're looking for that b value for the y-intercept. So the y value partnered with a 0 for x. In a table, we're still looking for that coordinate. So we need to look for an x value of 0. The y-intercept is the y value paired with it. And once we do that, we can fill in our equation y equals m, that slope, x plus b, whatever you have for your y-intercept. So we really just need to find the slope and the y-intercept, and we'll be able to fill in the m and the b in the formula. So we look at the first graph we have here. We want to find the slope first. Remember that when we're finding slope, we just need two really good coordinate points. I'm going to use these two. When I have a graph, I just need to count the rise and the run looking at the scale of the graph to find the slope. Okay, so my slope is going to be the rise and the run. Well, I have to go up 2 units, 1, 2, to get to the same level as the next point. Then I have to run 1, 2, 3 units to the right. So I'm going to have a rise of 2 and a run of 3. My slope is 2/3. That's half the battle. After this, all we have to do is identify the y-intercept, but that is a location on the graph. That's right here. That coordinate is 0, 1, so my b value is going to be 1. Easy peasy, y'all. All we have to do is fill in our formula. Y equals m x plus b. And we are done. That is the slope of that line represented in the graph. Sorry, that's the equation of the line represented in the graph. Okay, you guys pause the video right now. I want you to go ahead and try number 2. Find the slope, find the y-intercept, and plug those m and b's into the formula. Even if you picked 2 different points than I did to calculate your slope, we should, if we do the rise and run correctly, still end up with a reduced fraction that is the same. I started here and was trying to get to this coordinate point. To get there, I had to go down 1, 2, 3, 4 units from 5 to 1. Then I had to run 2. So I went down 4 and I ran 2. Negative 4 over 2 reduces to negative 2. So even if you picked 2 different coordinate points than I did, we should all get negative 2 as our slope. We then look for the y-intercept, which is where the graph crosses the y-axis, and we know that my y-intercept is 3, which means when we're filling in the formula, we have y equals negative 2x plus 3. And there we go. Now, from a graph is probably, in my opinion, the most straightforward because it's just locations on a graph and counting. But we can also do this when we're given a table. Now, when we're given a table, we learned how to still find a slope from this table, and we know we're looking for the y-coordinate that's paired with a 0 for x. So let's start with what we know. Let's start by finding the slope if we're trying to write an equation. Here's x1, y1, and x2, y2. All right. I have a formula that tells me if I take y2 and I subtract y1, put that over x2 minus x1. If right now you're like, Miss Quigley, where did you get that from? That is the formula that's right here. It's the formula on your formula chart for slope, the slope. y2 minus y1 over x2 minus x1. I throw that in my brain or my calculator, and I would get that negative 5 minus 2 is negative 7, and negative 5 minus negative 4, which is really like negative 3 plus 4, is 1. So my slope here is -7. I then am looking for the y-coordinate that's paired with x, but like I don't see a 0 here on my x's. But I do see that this is going -4, -3, -2, -1. That means the next box, I'm just going to draw it in, would be 0. All right, I know 0 goes there, which is what I want, so then I just have to follow the pattern. If I know my slope is -7, which means I'm subtracting 7 each time. 2 minus 7 is -5. -5 minus 7 is -12. -12 minus 7 is -19. So -19 minus 7 is -26. Now I know what's partnered with 0, so I know my y-intercept is -26. Once I know both the y-intercept, partnered with 0, and the slope from my slope formula, I just have to plug into my equation. This would be y equal to -7x minus 26. And voila, I'm done. You guys have the second table. This one is a little bit more straightforward. Please pause the video and write the equation for this table. So we first start by calculating our slope, y2 minus y1 over x2 minus x1 in this formula. We start reducing. You can throw all of this in a calculator, make sure you get it out as a fraction, or do it in your head. 80 minus 40 is 40, 50 minus 0 is 50. 40 divided by 50 reduces to 4/5. Then I look at the table and I see the y value that's partnered with an x value of 0, which means I know 40 is my initial value. It's where I start, so it's my beginning, or b. It's my y-intercept. Plug it one more time into the formula y equals mx plus b, and we're good to go. On the inside of these notes, we're going to take it a little bit a step further. We're going to do a question that involves some work here. So now the question is asking us to write an equation of a line that goes through the points 2, 5, and 4, 4. Use a graph to help find the y-intercept. All right, so they're letting us use this. So let's plot these 2 points. We go over 2 up 5 and over 4 up 4. There's my equation, or my 2 dots that I'm going to draw a nice, hopefully perfectly straight line in between. Voila. Pretty good, actually. And I know that I can see my y-intercept now. It's at 0,6. All right, I have my y-intercept. All I need now is a slope. So I'm going to use the 2 points, x1, y1, and x2, y2, and my slope formula to find that slope. y2 minus y1 over x2 minus x1. This would be -1 over 2, which we're going to leave as a fraction, please. And again, we know that my y-intercept is 6 because that's where this line crossed the y-axis when I graphed it super accurately, which means that I know my equation is y equals -1/2 x plus 6. Voila. So even if they don't give us enough information here, we have skills that we can use to create graphs that allow us to do these sorts of problems. Okay, if you get 2 points, you can always find a slope between them, and you can always graph them to find your y-intercept. Now I want you to try one of these. Now you might look at number 6 and say, oh, Miss Quigley, they did not give us coordinate points. And they totally did. Remember, this is function notation, and function notation is f of x equal to y, which means they still gave us an x and a y for each of these coordinate pairs. X, y, x, y. We can totally write these as coordinates, just like we learned in function notation. F of -2 equal to 3 is the coordinate pair -2, 3, and f of 0, equal to 5 is 0, 5. Now we have our x1, y1, our x2, y2. I'm going to let y'all think at this point. If you would please try to find the equation of the line that goes between these 2 points. Use the graph if you need help finding the y-intercept. Here's some things I would have wished you noticed here. Did you guys notice that they actually gave us the y-intercept in these coordinates? 0, 5, remember we're looking for the y-coordinate that's partnered with the 0x. So once we graphed it, I'm hoping that you realize that, oh snap, they gave us the y-intercept. It's 5. Once I found the slope either by calculating the rise and run of the points that I graphed or by using the slope formula like you see on my screen, we can write the equation y equals 1x plus 5. But I want to let you know that that works, but most of the time you're going to see that 1 turn back invisible. Because remember, mathematicians are lazy, so we find shortcuts and shorthands for everything. We know that an invisible 1 is in front of every variable that doesn't have a coefficient showing. So both of these are acceptable answers. You're just going to see this one more often. That's the better answer. Last way we need to be able to write an equation is from word problems. I love writing equations from word problems because they are real-world situations. Now there's a few keywords we need to look out for in regards to slope and y-intercept. When you're reading a word problem and you know it's going to make you write an equation in slope-intercept form, or any sort of time you're looking for slope, you're going to look for words like rate, aka rate of change. You're going to look for per, like cost per shirt, or you're going to look for words like each or every. So each costume costs $10 each, or $10 per costume. Those are things that help me know that that's the slope of my situation. Some words that give slope a direction may be like ascends, which means going up. It may be like fills. And slopes that mean I'm going down or I have a negative slope are going to be words like descend or go down or empty, because that's going out. So you do sometimes have to think about the direction, whether positive or negative, that the slope is having. There are also some words that mean the y-intercept in our word problems. Some of those words that we need to be looking out for are words like initial value, which you guys know is the same thing as the y-intercept. Initial value means where something starts or begins. So if you know in the situation they're telling you where something starts, begins, comes from, those are going to be your y-intercept words or values, because they're telling us the initial value or where that starts in real life. So for example, in this one we have a graph to help us out here, but it says a helicopter descends from a starting height of 35 meters towards the ground at a rate of 5 meters per second. The graph below shows the height in meters of a helicopter as it descends in X seconds. Write an equation to represent this situation. All right, let's highlight some of the things in this that we need. If we're looking for words that mean slope, we said rate, per, and each are words that we're looking for slope, and I see rate of 5 meters per second. That has both rate and per in it, so that probably is going to indicate that that is my slope. We do need to know what direction slope is going. But I see the word descends here. Descends means going down. Also, in my graph, this helicopter is landing. It's going down, so it's going to have a negative slope because it's coming back down towards Earth. The other thing that I'm looking for here is a y-intercept. It says a helicopter descends from a starting height of 35 meters. Starting height of 35 meters, that's going to be my y-intercept because that's where it's starting. Additionally, we can see that on this graph. It definitely starts at 0,35. All right, this real world problem comes from words and the graph, but since we already know the slope and the y-intercept, my slope being a -5 because it's going down, and my y-intercept being 35 since that's where the helicopter starts, I can fill in my equation easy. Y equals -5x plus 35. Voila. There's the graph of the helicopter as well as the equation that represents that helicopter's landing. You guys will help out the next problem. Audrey and Sarah need to fill the kiddie pool that they have in their backyard. It rained the night before, so there was already 2 gallons of water sitting in the pool. If we know that the water comes out of the faucet at a rate of 11 gallons per minute, write an equation that will help Audrey and Sarah fill up their kiddie pool. You guys have this one. Pause the video and give it a shot. All right, here's what I noticed. I noticed that this equation is going to have a slope of 11 because the problem tells us that the water comes out of the faucet at a rate, there's a keyword, of 11 gallons per minute. Okay, so it's filling up. That's going to be a positive value because we're putting water into the pool. Even though I didn't see that, I know that that's what's happening in this real world situation. This is going to be a positive slope. I also know that even though it didn't say starting, it says it rained the night before, so there was already 2 gallons of water sitting in the pool. We started with 2 gallons of water already chilling in our kiddie pool, which means that my y-intercept is 2. That's where we're starting. So very easily I can fill in the formula. Y equals 11x plus 2 is the equation that represents filling up the kiddie pool for Audrey and Sarah. Remember, our goal of the day was to be able to write equations from various situations, from a graph, a table, or from a real-world situation. And all we need to do every time is find the slope, find the y-intercept, and plug it into y equals mx plus b. See y'all in class.